Welcome, Chapter 5, IT Infrastructure and Emerging Technologies. Let's take a look. So what are our objectives this week? We're going to learn what IT infrastructure is, how it's evolved, some different components of it, the hardware, software components. We're going to look at some computer trends, computer software trends, and what challenges does all this mean for management information. So, what is IT infrastructure? A set of physical devices of software and hardware to operate an enterprise. Set of firmware service includes computing platforms, providing computing services, physical facilities, IT management, education. And this is what we're going to be looking at. How does all this work and come together? When you sit down at your desk, when you're at work, you expect there's certain things that are there that are going to help you. When you log in, the computer's going to do what you need it to. Your applications are there. Well, here's the thing. How did all that get there? Someone had to design it. And that's what we're going to look at. Basically, we're going to look at the evolution of IT infrastructure. We started with mainframes in the late 1950s, early 60s. These are humongous pieces of equipment that took up entire rooms in buildings, very specialized computers. They were mainframes and some mini computers, but basically they housed everything. You had dumb terminals that would connect to them. It was a green screen that you would also connect. Everything was nice and simple, all text-based information. These were the first computers that were used, mostly in accounting, and then it slowly rolled out to all the other divisions. 1981, personal computers were invented. IBM was the first one to get it out there, and it started helping the computers, employees do their job better. That was the whole purpose of this. In 1983, we had the client server, and what that comes down to is we have your PCs on your desk, but all the computing power is done on the mainframe. So basically your PC was what we would call almost a dumb terminal, where it didn't have tons of data on it. But you're able to do some simple things, but all the main data was served on the main server. We're kind of heading back to that. Now in 1982, we were looking at enterprise computing. This is where it was the first came together. It started out as a ERP system. It actually started as MRP, Material Planning Resources, and it was in the manufacturing, making sure that whoever was doing their job had the tools they needed to do their job. This eventually rolled into ERP systems that we know today, where it kind of puts the whole system together. And now we're looking at cloud computing. With the technology advancements coming up, we're able to store information on the cloud. We're able to actually have applications on the cloud. So what does this mean to an individual? You can log in from anywhere. Your hardware connects to the internet, and all your applications are there. So it doesn't matter where I'm actually working from, I can use the internet. Some basic drivers that have come about throughout history. Moore's law in microprocessing power basically says every 2 years it doubles. Law of mass digital storage, again, the amount of data being stored each year doubles. So we're looking at a lot of information now that's being stored. And Metcalfe's law of networking economics. Value or power of the network grows exponentially as function in the number of network members. So basically saying the more people that need it, that we're able to provide that for them. If we look at Wi-Fi, looking at it. Also, we're looking at the declining communications cost. When you started using the internet, you paid per bit, per byte, or per gig. Now we pay for, but as there's more people using it, the costs have come down. And in many, when you traveled, if you went to McDonald's or Starbucks, you had to pay to use their Wi-Fi. Well, now it's just a given that you're going to be able to use it for free. Standard networks. Technology standards. The standards we've had in here have been very specific, and it allows us to have that information so we can have that communication no matter what network we get on. So let's take a look at some hardware. client machines. These are your desktops, laptops, mobile commuting, smartphones, tablets. And these are basically what we use. This is what the user uses to interface with our applications on a daily basis. Whether you have a desktop, PC, or laptop, you know what it's on it. You can use it. You move around. We've moved to the mobile networking now with laptops, tablets, smartphones. That enables us to have this information wherever we go. Now, we'll talk more about the ethics of that later on in this class, but you're able to stay connected anytime you go. Right now we're teaching an online class, and we're able to do this because of these smart mobile communications that we have. Now, servers are usually sit in a locked up, air-conditioned room, humidity controlled, and this basically houses where all our data and main applications are. So our databases are there, which we'll talk more about in upcoming weeks, but it allows us this information to have on here. And we have our mainframes. Our mainframes are old systems that did a lot of the work back in the 50s, 60s, and 70s, and some are still around today because of the amount of information that's on there that we're not able to get these off of the system because of whatever the reason is. But a lot of mainframes still exist because of the amount of system on there. But basically, we can look at the banking systems, HR systems. That's where a lot of mainframes still house that. Basically, we have a few different operating systems. The operating system is what we use. If you on your server, almost all of them are either Windows-based or Unix or Linux-based. Linux and Unix are similar. Linux is a free version of Unix. But basically, these are the servers, and these allow multitasking, so we can have a lot of different things going on. We can have multiple CPUs in these. It's not uncommon to have a Unix machine running a dozen CPUs. Gigs upon gigs of RAM to make everything run more efficient. Same with the Windows machines. Client level, which is what most of us look at. We run Microsoft Windows, we have Androids, and we use Google Chrome. If you notice, what's not really on here a lot is Apple. Apple doesn't play nice with the large systems. That's why it's a whole nother issue, but these are usually what the client systems run. Then we get the ERP or enterprise systems. These are large systems, and basically what these do is it brings the entire system, HR, manufacturing, sales, human resources, everything into one area. And so when a salesman goes out, he can put in the information right when he's at the client, puts his data into the system, it goes right to finance, they'll get credit right away. When it comes in, it goes to manufacturing, they know where they're shipping into. So it gets put in once and everyone knows where this is. So the two largest ones, SAP and Oracle, and they allow us to have this information. And then some of the other middleware providers which allow us to talk to old systems and new systems and translate data for us, IBM and Oracle. Data management systems. We're going to spend a lot of time on databases. I believe it's next week. But basically, there's a whole bunch of different ones that are out there. Database software providers are IBM, Oracle, Microsoft, Sybase, MySQL, and Apache. These are the big ones. There are a couple smaller ones out there. But really, IBM and Oracle have the majority of it. Microsoft SQL is for smaller servers. But for large corporations, you're running IBM or Oracle because they're the most robust. They are scalable. They can have tons, millions upon millions of lines of information stored in them, where some of these other smaller systems don't allow that. That brings us to the networking. All this comes together that we have to network it all together. So networking the operating systems, we have, we talked about Windows servers, Linux, and Unix. They're awesome networking. But some of the large networking hardware providers, Cisco's the number one, and Juniper is the other one. They provide all the backbone that we don't know about. They provide the routers, the hubs, the switches, and a lot of this smart networking that allows us to communicate. All this goes through the telecommunications or the phone lines, cable lines, and that's how we use everything. Everything is, this infrastructure's been laid down, and we're still using it. To have voice over the internet and stuff like that. Then we get the internet platforms, hardware, software, this is all comes together, web hosting, and again, the routers, the cabling, the wireless communications, all this. And whether you use a cable on your laptop or not, but cable is faster than using wireless because of the standards and all that good stuff. But anyway, we're not getting into that. Internet hardware, again, IBM, Dell, Oracle, these are some of the things, and the development tools. Everything we look at has to be developed when you go on a website, and we'll talk more about that in a second. Here's the thing. Consultant is a big part of systems integrations. Even large firms don't have the resources or the expertise to do this. So even some of the global services, IBM, HP, Winpro, these allow systems or small companies to use the infrastructure to build into it, and it allows us to have this information in there. So consulting is a big part of everything we do. So what are some of the upcoming trends? As we talked a little bit about, we have mobile and digital, smartphones, notebooks, tablets, wearable devices. This is what we're in the process of coming into right now, and a lot of this is no longer developing but current trends, but this is what's happening right now in the computer system. People are using the smartphones to communicate. You get your email delivered to it, so you're never too far from it. A lot of companies bring your own devices, BYOD, and it forces, so what happens with that is, I know I'm going to give you a credit of $1,000, you're going to buy whatever PC you want, and it's up to you to maintain it. It reduces my cost because I don't have to maintain it. It's up to you to make sure you have all your right systems on it. Now, that does come with some drawbacks, which we'll talk about in a little bit. Some other areas that are up and coming, quantum physics. And basically what this is, it increases our computing speed. And it's really made some large advancements in it that we're going to be looking at. Virtualization, we found that this does help a lot, especially in the hospitals, with helping people figure out what to do, how to do it. And it reduces hardware, allows us to have this. Cloud computing, that is the other big one we're looking at right now. As the internet has gotten faster, we're able to store information on it. There's three major types we're going to be examining: infrastructure as a service, software as a service, and platform as a service. So if I'm a small company, I might not be able to afford to spend a lot of money on infrastructure. Well, here I can just buy it what I need. As I grow, I just keep paying for more. Software as a service, I don't need to have it on my laptop. If I can get to it anywhere in the world, well, why not have it available? Same with the platform as a service. It allows me to have this information. So this is becoming a lot of the big push for everything. The biggest drawback, security. For sending over the internet, pretty much anything can be hacked. So we have that whole thing. And reliability. If you don't have internet service, you're going to not be able to get to what you need to. As we're understanding the impact on the environment, green computing is becoming a really big issue. What do we do with all your old equipment? What have you done with your old equipment? Did you just dispose of it in the garbage? There's a lot of toxic things in our PCs that we don't really know about, but they're there. What do we do with it? What about the fact that to keep a data center cool, a small data center, size of a standard living room, usually takes a huge amount of electricity, huge amount to keep it cool in the summer and keep it warm in the winter. And keeping it the humidity exactly right. These are extremely high costs. I know what some companies have done. They've gone up into the Rockies. They've built their servers up there, and they're using the natural cold to help keep some of these things. If you take a look at some of the videos out there, Facebook, Google, these are what are leading the charge on some of these things. Some other things, Linux, as I mentioned, is a free software, but it allows for a community of programmers, and they help find bugs and fixes it. So it's not a lockdown browser. Anyone can get to it, and they're able to produce open source code is what it's called, and it allows us to have this information so anyone can be doing this. We have other web servers, XML, service-oriented architecture. These are just some of the areas that allow us to have this information available for when we're working. You know, one of the things we need to do, whether as a firm changes, if it gets smaller or grows, it needs to have scalability. Scalability is the ability to relatively quickly adjust the size of our network. If we need a surge of people for summer help, well, I might have to add 50 users, and then at the end of that summer, they go away. We have to take it down. And why do we want to pay for something we're not going to be using? So scalability is an important part of the infrastructure that we need to deal with. Then we're going to look at the governance. Who controls the infrastructure? Should it be centralized or decentralized? Should everything, if I have satellite offices, does everything go back to the main branch? Think of a bank. They have all these branches. Where's all that data stored? Is it centralized where there's one place, let's say in the middle of the US, where all the banks send their data? Or is it decentralized where all the data is sent at the regions at each individual office and then it's sent up at night? There's different divisions, there's different schools of thought on these. Whether centralized or decentralized better, it just depends on what our infrastructure looks like and what we want to look at. Total cost of ownership, we're going to look at this. What is the cost to have hardware and software? How much does it cost to install, to train, to support? Downtime. You know, if you're Amazon, how much do you say they lose? Millions upon millions for every hour that they are down, because it's a worldwide service. So what is the cost of that downtime? Some competitive forces up there, you know, market demand, firm services, firm's business strategy. What are we looking at? And we have to look at our competitors. What are they doing and how can we make it better? So that was pretty much chapter 5. So I hope you do that. If you have any questions, don't forget to ask. And remember to smile.